Looking up to the next problem. This is probably your worst case, or I don't know, what you will probably receive. If you plug in -5 for these values, you would find out one of the three case scenarios. So it would be undefined. So how do we actually solve these? We do something called algebraic manipulation, where we basically look for holes to cancel out, so they wouldn't be undefined. With that being said, as you can see here, there's a difference of square here. So let's expand our function. So x, the difference of squares is x minus said number, which is 5, and x plus 5. If you combine these two, you would end up with a -23. Add these two together, then that would be +5 plus -5x. They also cancel out. X times x to the power of 2. All right, so now let's do the bottom side. Let's just do our normal x way. Since we have a 1 as a leading coefficient, we do not need to do anything with the last coefficient. So -15, and we have a +2. So now let's find factors of 15. 15 can be split into 5 and 3. Can we get to 2 using 5 and 3? Yes. So let's use 3 and 5. Since our biggest number here, since this is positive, that means since our number here is positive, that would mean that our biggest value of here would be positive. So leaving with the other as negative, since you need to get a negative number here. So our bottom graph, our bottom function would be x minus 3 times x plus 5. As you can see here, x plus 5 cancels out. So we canceled out our whole. That would leave us with x minus 5 all divided by x minus 3. Now we can plug in our negative value, our -5 for x. So -5 minus 5, that would be -10. -5 minus -3, that would be -8. Simplifying this fraction, you would be left with a positive function, positive value, since plus, these cancel out, and you're left with 5 divided by 4. So this would be our limit as x approaches -5, and for the limit as z approaches 3, this would be our limit. Limit also being the height.